So as you can see on your screens, topic we've selected today is highway engineering, analysis and design of rigid pavement. So my aim with this topic and developing this course is to familiarize you all with the design of highway alignment, the geometric design of highways, and rigid pavement design, and all the associated codes with these. There are many aspects that contribute to construction of pavement structures, and through this presentation, we will see and understand the various roles that go into the construction of highways and its related literature. By the literature, I mean all the standards, the codes we have, and these are not only limited to the Indian codes that we have, that's by the Bureau of Indian Standards, but also the American codes that are associated with this, because we should understand all these codes have been developed, all the designs have been developed by the American Association of State Highway Officials who had conducted the ASHO test on the roads. So our domain will include the IRC codes, that is the Indian Roads Congress. I would like to, I would want you all to be familiarized with IRC, with MORTH, that's the Ministry of Road Transport and Highways, and some people call it the Orange Book as well. All the associated IS codes, along with some American codes that are the ASHTO codes. ASHTO is American Society of State Highway and Transportation Officials, and their manual series that goes like MS2, MS7, and also how we calculate the basics from doing a traffic survey and converting that into the load specifications that we need to design pavements. So these are the topics that I'll be covering in today's presentation. I would first want to introduce the topic, and before getting into the specifics of how what design is and how the design should go in, we should understand why you should study highways, right? Because everyone will have the question, why such a specific topic that's been selected for this course. Then I'll discuss what the benefits you can reap from this course itself and give you the overview of what all will be included in this course. And then what the fundamentals are that go into a highway, and then we'll see what teams are involved in construction of pavements, because this is all a team game. It's not a one-man army. So you have teams that go into execution, you have teams that go into design, you have teams that go into the survey. So in this particular slide, you will be able to see the various domains that you can be a part of in highways. So it's not necessarily a person needs to be into design. If a person who's interested in site activities, they can go into the construction. If someone who is interested in surveys or maybe doing the quality work, so they can go into quality control. Then we have the safety, health and safety teams, which are basically looking after drafting all the health and safety guidelines that you need to practice on the site, so that you have a successful project with a safe team. Then you have the environmental teams that go into, so the many domains that you can be a part of. Then we'll have a demo and a case study that will be a part of this course, in which I will share some of my projects that I have worked on in the past few years. Let's start with what highways are. So highways, pavements, freeways, everything. The most costliest part associated with the highway construction are the pavement. There are two basic purposes of providing a pavement. One is to help support the vehicle loads, and to provide drivers a visual perspective of horizontal and vertical alignment of the path. So we all know, we all drive our cars, we all commute from one place to the other, and we all know how important pavements are for our daily life, and they also contribute heavily in the infrastructure industry. So just bringing up one of the facts, that India has the second largest road network in the world of approximately 4.3 million kilometers. And to understand the depth of what we have in highway construction, we can easily see that there are so many government departments who are working on the development, who are working on the maintenance and rehabilitation of highways and pavements. So it's not limited to one government department. We have CPWD, we have the National Highways Authority of India. If we go towards the east or towards the border areas, we have the BRO. We have the MES doing the highway work for the defense. We have the state levels PWDs. We have municipal corporations. Like if we talk about the north, we have development authorities in Haryana, we have development authorities in Punjab, and that too also in one state itself. We have multiple development authorities who are looking after highways. So we can clearly see if we need so many teams, if we need so many government departments for the development and maintenance of these highways. So how much money is being spent by the government and how much scope we can have pursuing this specific field. I have been in this field for the past 8 years, and one thing that I've observed is that we don't have many, um, you know, professionals in this field. We have many beginners who come in, but again, they are there with limited knowledge. If we have people who have good experience, who have good projects under their belt for highway construction, highway design, highway maintenance, I think we can reach miles. I mean, we have so much coming in our pipeline within India itself. So now talking about the pavement structures, we have in the basics, we have three kinds of pavements that we all know. Those are the rigid pavements, as you can see in the pictures as well. We have the flexible pavements, that's the asphalt pavement or the bitumen pavement that we call. Rigid pavement is of concrete. Then we have composite pavements, which are a combination of both. That is a rigid pavement underneath, overlaid by flexible pavement. We have some more types of pavements that are like continuously reinforced pavements and post-tension pavement, but those are specific designs. So basically, the classification is in three categories. Now, why should you study highways? This is one part that you all will be wondering about. Now, as I told you, within the infrastructure market, highways play a very important role. The infrastructure industry is booming in India right now. Just last month in August, we had an article in the Times of India of 23 new expressways and highways coming up in the next 5 years. So these are the new highways, and the approximate length of these expressways will be 7,800 kilometers. So 7,800 kilometers in length needs to be constructed new, and the amount that the government has sanctioned for this, has kept aside for this, is rupees 3.3 lakh crore. So you can easily understand how big this industry is in itself and how many people this is going to employ. So we need to focus on that right now. In addition, the government is planning to involve P3 business model in the construction. So by P3, I mean is the public-private partnership. So what we'll do is we'll try to touch basics of P3 business model as well in the course. So in this, what we mean is the private players, the companies who are coming into construction, they make a joint venture or they come in by themselves. And like we have mostly, we've got toll plazas on the road. So that is a model, that is one part of a P3 business model in which the company generates its revenue by charging the people by itself. Also, in this particular business model, they are also responsible for the maintenance of the specific highways or whatever business that they are part of. And in the end, after the completion of their whole contract, they give it to the government. So this is in all better for the government, better for the taxpayers, better for ourselves when such a business model is being promoted by the government. Going back above to the above points, 7,800 kilometers for 3.3 lakh crores, and this is only the construction of a new highway. Now, when we walk to different phases of our life, we see every day or every in summers specifically, highway construction is going on. We have the departments, government departments, they're overlaying the existing roads, the asphalt roads. They are overlaying them. So that will come under the rehabilitation of the highways and pavements. And this is a continuous process. So this is a major part of the money is being invested on the maintenance of the highways. That is one thing that we can also look into, because within this course we are going to cover the failures of the pavements as well. So when we are covering that, we can really understand on, we can really expand our domain of where we can be a part of, where we'll be involved in such big projects. So what are the benefits of this course? At the end of this course, what you will be able to do is you will be able to conduct design of highways. You will be able to conduct the design of rigid pavements. You will be able to understand the geometric design of highways. By the geometric design, I mean the horizontal and the vertical alignments of the highways, super elevations, so horizontal and vertical curves. In addition to this, you'll be able to understand what types of failures that occur in the pavements and what are the rectification or the rehabilitation measures that need to be taken for those failures. And also calculation of earthwork, including drawing of L sections and cross sections of the pavement. This is another very important aspect in the pavement design. By calculation of earthwork, I mean is the cutting and the filling. Whenever we are constructing a highway, we need to have a proper level for that specific pavement, for the specific road, so that during rains, one road is not too high, the other is not too low, because that will lead to flooding. We need to maintain a proper grade of the roads so that the water goes in one direction. So if you see many well-planned cities, they don't there's not much flooding in those cities. Why? It's not just because some people might say the rains are not that heavy. No, the rains are very heavy in those parts as well, but the thing is they have a proper grade maintained. The water goes to one specific area which they've designed, that is the low-lying area of that city, and that is all contributed because of a proper grade that's been provided to the roads. So L section is the longitudinal section, cross section is the transverse section, how the pavements will be designed. In addition, there is another concept called hydroplaning, in which when the water accumulation on the road is so high that it can lead to accidents when the cars can slip. That has been observed heavily in the States, in the USA, and other Western countries, because there there have been many faults in the highways which have not been corrected in due course of time and have led to many severe accidents. So that's about the earthwork. Then we come on to the traffic surveys. This is one of the basic inputs that give you how to design a highway. I can design any highway, I can design any pavement that can withstand a load of, say, a rocket ship. But when it's not going to serve that purpose, when I only need, say, 10 trucks on that road to travel, why should I design for such a heavy load? So those are the basics of design. That is why design is needed. You can, anytime you can over design any structure, you can over design any pavement, any building, but if it's not serving its purpose, then it's just the wastage of the national resources. So your design should be optimum. It should be enough to cater to the loads that will be actually on that surface. So that is why traffic surveys, they give you the basic loads that you need to design the pavement for, that the pavement needs to cater to the load. So that will be determined by traffic surveys. In the traffic surveys, what we are going to cover and what you will, at the end of this course, you will be able to know is the level of service of each highway, how it should be divided. There are many terms like level of service A, B, C, D, E, and F. How are they determined? How the traffic count of vehicle goes in, how you want to, how the loads are calculated, the traffic loads are calculated. What is ESAL, that is the equivalent single axle load or equivalent single wheel load, ESWL. How the design of highways goes into, like, what is the number of lanes that you need to keep, what is the lane width that you need to maintain, whether you need to provide a median on that specific pavement or not, and what should be the width of that, what should be the length of acceleration and deceleration lanes, what should be the curve of the radii. So these all are influenced by the traffic surveys, how, what kind of traffic you have. And when you're designing a new pavement, obviously you don't have the traffic data for that. So what we do is we find a similar pavement and conduct traffic analysis on that road. So this is what you will, at the end of the course, I believe you will be able to understand. And for this course, I only need three things from all the participants, and that's sincerity, sincerity, and sincerity. So if you sincerely do this, if you sincerely do what I have devised, you will be able to, from scratch, you will be able to design a highway, you will be able to maintain a highway, you will be able to understand what are the ins and outs, what are the little things that you need to manage for an efficient highway design, for an efficient construction of a highway. So we are here to answer all your questions, whatever you have, myself and the team at Skill-Lync. For any questions you have, anytime you can come to us and we will be glad to answer any of your queries in this topic. So covering the overview of this course, we will be doing the geometric design of the highways, that is the highway alignment. As I told you before, the horizontal curves, the vertical curves, the super elevations. By horizontal curves, I mean the simple turns that you take on a road. What should be the radius of that curve? If it needs any uplifting from the outer edge, that is the super elevation, to cater to the centrifugal force that acts on the vehicle when you are maneuvering a curve. Vertical curves are the ups and downs when you go on commute through a like we have many when you're commuting to a highway from a say a service road or a normal road. When you're coming to a highway, many a times you see a clover leaf bridge, and when you're commuting through a clover leaf, you see there's a very sharp turn before you enter the highway. On that is a combination of both horizontal and vertical curves. That is also what we're going to touch base on in this course. And what is the super elevation that needs to be provided on that as well. Then we're going to come into the design of pavements, what the different layers in the pavement are, how do you need to cater to the loads that are required for that, and what should be the subgrade, that is the lowest layer that I'm going to cover in the next slide. What are the basic requirements of that layer? Traffic data collection and analysis. How can you collect the data? How can you assemble the data in a way that is we call as calculated in MSA, that is the million standard axle. When the ASHO test, as I informed you earlier, was conducted, it was conducted on a pavement of known thickness, and the loads were also known. And they wanted to understand the behavior of the pavement based on that load. So that was a very in detail test that was carried out by ASHO, that is the American Association of State Highway Officials. So when they carried out that test, so they knew what the traffic was, they knew what the different layers of pavements were. That is the first 2 points of the design of pavements, and they saw the behavior of the pavement with respect to those parameters, and how the different components of each layer of how the different components of each pavement behave. So that is what we are going to cover in this course as well. So we're going to compare IRC 58, that is the Indian Roads Congress 58 2015, and we're going to compare it with the ASHTO design as well. We're going to cover the failures in rigid pavement and the rehabilitation measures that need to be taken for those failures, whether you need to construct a new road at all by demolishing the earlier road, or you can take some rectification measures that the road will or the pavement will function effectively for the next 5 or 10 years. Coming to the fundamentals of what a highway is. Now, the first thing that you see is the subgrade, the lowest layer. What we want when a vehicle commutes on a pavement, the load should be transferred to the ground safely without damaging any of the layers above. So the ground on which the load needs to be transferred, that is called the subgrade. The subgrade is basically the soil, and we need to check the soil conditions before designing any pavement. I've seen in the past many of my projects, the roads failed, the roads cracked up, the roads opened up, just because the subgrade was not designed, the subgrade was not tested, the subgrade was not designed effectively. So after the subgrade, we have got the base course. The base course is basically consists of granular materials. This is also called the permeable course, because when we have rains, where can the rainwater dispose of? We want the rainwater to go safely into the subgrade and to the ground. And this is the layer that does it. So when we compare flexible pavements to rigid pavements, In rigid pavements, we may be having only one layer of the, that could be a granular layer, or that could be a cemented layer itself. But when we come to a flexible pavement, that's a bituminous pavement or an asphaltic pavement. In that pavement, this base course consists of multiple layers. We can have a sub base course, then we can have a base course. That base course can also be divided into granular course and an asphaltic or a bituminous course itself. And finally, on the top, we have the wearing course. The wearing course is a non-permeable. It's a waterproof coating that gives you a finished surface on which you can commute at the design speed as well of the vehicles without any toppling of the vehicle or without any accident. So there you can see there's a conical shape that I've provided on the top of this on the top of the wearing course that you can call as camber. I hope you might all might have read about camber in your engineering course. The basics of that also we'll cover within this course. That's the camber that can be used to dispose of water, or we can rise the outer edge of the pavements in case of a curve. So that will be the super elevation. So these are the three basic layers that go into a highway construction. And all these three layers are designed specifically, number one. Secondly, when you're executing the work on site, the quality control teams monitor this very specifically that will they meet the desired specifications or not. Now, I'll give you an example here. In the base course, if we go to the sub-base layer, sub-base course, there's another one part of the base course. We have got 6 gradings. We've got 6 types of sub-base course that can be used in a highway. Now, which specific will be used? And all these specifications are given in Ministry of Road Transport and Highways, that is the MORTH, the March 5th revision. So which of the 6 types we can use? That is also what we're going to cover in this topic, because many layers, they come with low permeability, like a few millimeters per day that they can water that can seep through these layers. But we need, as per the design in say heavy rainfall areas, we need at least 300 meters per day. That should be the capacity of the sub base course and the base course to transfer the water to the subgrade. And also one thing that we need to make sure is, because this is a permeable course, that is the base course, it has high permeability, so we don't want its pores to be blocked. So how do we take care of that? That is also one aspect that we need to look into.